Go on.
Okay, so open the answer workbench, the versions 2021, and then we are going to continue the model that we create in the previous class. So the geometry is done. So in this part, you have to click on model. Okay, remember that the geometry is done. Okay, so click on model. Okay. Can you see that this is the bridge drawn by lines? Okay. Okay, so this is the line body, right? And the materials in the lower part, you have to assign the property of the material. So in this case, by default, ANSYS use structural steel. But if you create a new materials, the new material appears in this part. So you select the material that you create. Okay, but structural steel will use in this part. And then you have to generate the mesh. So click on mesh. Okay, you see some options in the lower part in the element side. So if you don't put any value, the program and do the mesh using an element side by default. But in this case, we use an element side equal to the 20 millimeters. Okay, 20 millimeters. And then right click on the mesh, and generate mesh. So you see the side of the domain, side of this mesh, that is 20 millimeters. If you change, for example, 10 millimeters, and then run general mesh, you see small parts. Okay, so what else? Then you have to specify the tactile structure. Okay, so in the tactile structure, you have to set up the boundary condition and loads. So for that, you have to right click, insert, and in this case, we insert 3/4 and 2 simple support, right? So you see every option for the loads and the boundary condition. So 3/4, insert 3/4, 2 and 3. And then insert simply support 1 and the other simply support. So then immediately you see that these force and simply supports in the left part, you see the sign, okay? But because this is because you not complete this, do not complete or set up this force or the simple support. You have to specify the point and the value in the case of the force, right? So, for example, the force ones, you have to specify the geometry. In this case, you have to select a point in this point, okay? So in the second point, in the first element, and then apply. So also, you have to define by components, and then enter the value of the force in the y component. So this is minus 7, right? $400. That's the same for the other force. Specify the point in the middle, apply the geometry, define by vectors, define by components, and put the force in the y component. This is minus 747,400. The same for the other force. Okay, select at this other point, apply in the geometry, define by components, and then specify in the y components, minus 78,400. Okay, then, so simple supports. So one simple support for the each end. So the first simple support, so you can rename. So simple supports left end, and the other renames and right end. So this left end apply in this point, and then apply in this geometry, this point, and the other simple support in the other end. That's so you see that this is the force and the boundary condition, simply supports in the end. Okay, and there is a question for any student. Is there any questions? Or
why don't you ask somebody specifically?
okay, let me for example, bias. Do you have any problem? You can follow my explanation.
Yes, doctor. Yes, engineer. But in the extremes, why is simple support and not clamp?
Because I consider the worst situation. But you can,
okay.
as a doctor says, you can use first simple support and then run the program with the fixed support and compare the results.
Thank you, engineer.
Yes. Okay.
Okay, Mr. Valles, how would you change from simply support to clamped, those ends? How would you change? Can you do it?
With boundary conditions.
Okay. Is that correct, Isaac?
More or less. In the boundary condition, but how? What is the step?
Everybody
the path.
try to answer that question, please.
What is the step of the path that
Like
you
instead of-
follow? Okay.
The
Instead of
steps
putting
are,
simple support, I just put in fixed element.
Okay, Peralta. Or
if I want to change the simple support, I have to first delete the simple support that for the right and the left end. Then I have
Okay.
to click in support in the in support and choose the fixed support, and then I
Okay.
have to set the parameters.
Okay. That is the answer. Okay.
I have another question. That is the configuration for a linear body. What happens if I have a three-dimensional body? The steps are the same or something changed?
In the three when okay. So,
I mean,
okay. Okay, o sea, when you use, remember that there are three types of elements: line elements, surface elements, and solid elements. So when you use a 3D problem, for example, in the solid elements, you can specify just displacement. Just you can specify just displacement. If you use, for example, surface, you can, for example, this option will appear the same options, but when you use solid elements, for example, simple support is not appear. So you can use displacement. Is this displacement, these options is similar to the simple support or fixed support? Because just if you use, for example, if you use displacement, you can put or set that the restriction in any component, in the Y, X, and Z components. Peralta.
Yes, engineer. It's clear.
Okay.
Yeah, we
Thank
have to be certain that when engineer Isaac made a zoom of the structure, okay, of the beam, it looks like it was a surface, but it's not. Right now, you are modeling, you are analyzing the structure as it is composed simply by beams, okay? So all what the program does for you is that you define the section as an I section, okay? So internally, he calculates the properties of the section: area, inertia, polar inertia, area for shear, things like that. But after that, he goes back to chapter 2 in our class notes. Joints, connect them two by two to define frame elements or beam elements. Okay? Be patient. In the next session, Engineer Isaac will explain you if you want to model another structure or the same structure, the same beam, the same bridge, but using plain elements. Okay, you can do it. But the problem is that you will see that the amount of work and the amount of computation is much, much larger. So this is a very simple model. It's the first one that we're going to do in this class. Okay, so the key word for this is model. How do you model this bridge? In this case, we are modeling this bridge as beams. So you have two joints, and the element between these two joints is a beam. Okay, go on, Isaac.
Okay. And then, the boundary condition alert is done. So then you have to specify the solution that you want to see. So you have to click on solutions, right click, insert, and in this case, deformations, directional deformations. Okay, so directional deformations, in orientation, you can set up the direction that you want to see, the x-axis and the y-axis. So in this case, I want to see the x-axis and the others deformation, directional deformations in the x-axis and other in the y-axis. Okay. So also, I want to see in the view results, I want to see axial force. So I want to see for reactions. For that, use probe, and then select the 4 reactions. Okay. When you specify force reaction using probe, so you have to select in what point, on what support you see the 4 reactions. In this case, it's the same for any support. So select simply support the left end, and that's all. So finally, you have to click on solve. Okay, click on solve.
People, any questions? People?
What happened?
Is everything fine? Was everybody able to
Mine
get up
is
to this point?
the same.
Did you get this to the same point, people?
Maybe there is an error. Simple support. Simple support. Ports. Simple support. Let me and then solve again.
Engineer, in the static structural not generate.
But this is false, 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 and simple support in this part and the other parts. So let me. I did in the last night. Let me. I don't know what happened, but I did in the last night, and this is the same.
Okay, what we can do is let's take a break here, okay? So you can fix it in Engineer Isaac. When we return, he would explain what was the problem, and then we will proceed to the example that it is at the end of these notes, okay?
Okay.
Okay, so let's take a break, a second break, and then when we return, exercise.